Hi everyone, David from Aberlink here. In this quick video I'm going to show you how to utilize pauses within a program. So we have a range of examples that we can cover on where they're typically used, and yeah, I'm going to show you how to insert it, how to utilize it, and how to then run it in the program. So let's dive in. So this is example 1, and in this example we're going to utilize pauses and some move wires to help us visually align the Z rotation of the part. So you can imagine when we have a part, it's theoretically floating in space. We'll locate it in Z via sitting it on the bed, and this angle bracket can be used easily to locate it in X and Y. The only thing that's then free to move is it's free to spin in the Z, and that is a very tricky thing to fixture. It costs a lot of money, or you need to design and spend a lot of time designing and 3D printing special fixturing to hold it. A quick example of that is something like this. So this allows the slot on the bottom to align, sits in and locates. So that's one way to resolve the issue, but if you don't have a 3D printer or time to design said fixturing, then this option of using a pause and some move wires saves you a lot of time and money. So in this system I've got the plane, the outside diameter circle, and then a midline from the slot. The idea is we're going to utilize some probe moves and a pause to drive to where the CMM thinks this slot is. So you can imagine the probe will drive down to a certain position, and then the pause will allow us to visually rotate the part on the Z axis until it visually lines up with the stylus. We then press enter, and because we've got it visually close enough to the reference system previously, it will find the reference features fine, clock itself in, and run the entire program. So let's have a look at doing that now. So here's the program I've already created, and the goal is to insert move wires and a pause at the very beginning of the program. So that means we need to insert them into feature number 1. So whatever feature number 1 is, that's where we want them to be. In this program, feature number 1 is the reference plane. So the goal is we'll right click on that, and we're going to insert the move wires and the pause into that feature at the very beginning of the code. The next thing, before we actually insert them and put the details in, we need to work out what those details are going to be. In Aberlink, the origin of the program is obviously from the reference system. So in this particular case, it's the center of this circle aligned through this line. That's the middle of the slot. And just for reference, in case you're unsure, anything away from us, so away from us in the y-axis, or to the right on the x-axis, or straight up in the z-axis, is a positive value, and anything pointing to the left, pointing towards us, or pointing down is a negative value. That's important so that you don't get the polarity of your positions wrong, which can obviously cause a crash. And in this example, we need to decide where we're going to put the pauses and the move wire. Ideally, I want it slightly above the face, so the Z values will be something around 5, but I'm going to insert a couple of move wires to traverse directly above the point and slowly come down. And the X value is obviously going to be 0 because I want to sit it centrally aligned through the rotation. And then the Y position, I want it somewhere near the slot. I don't want it too close inside this diameter, so I'll probably put it on the edge of this diameter. If you're ever unsure, you can just create the dimension roughly, and again that's giving us roughly a 107 diameter, which means I want my Y value to be 53.5. Okay, so now we know that, we can right click on the plane. Again, this is feature number 1. It's very important. We need to do these alignments before any contact points are taken. So the way to do that is to insert them into feature number 1. I'm going to double click this bar at the top to maximize the window, and then I'm going to click on CNC. That's going to open up the code as well as the template modifiers for the feature. Now I want to insert this before any approaches or contacts are done. So I'm going to right click on approach 1 and say insert above, and you'll see I have a range of options. Now the goal here, and this applies to most setups, I like to insert 2 move wires, then a pause, then 2 more move wires. The idea of that is the move wires are basically positioned the same in X and Y, but they have slightly different Z values, and that helps us navigate around any obstacles that might be in the way. They're not specifically required in this example, but it helps in most applications, I would say, to insert 2 move wires, a pause, and then 2 more move wires. So the easiest way to do this is to insert all 4 move wires. So right click on approach 1 again, insert above move wire, repeat this process 4 times, and then you'll see on that 3rd move wire, if I right click, insert above, pause. So we have 2 move wires, then a pause, then 2 more move wires. Now remember, I want to have these positions in X and Y at X0, Y 53.5. So what I'm going to do is I'm going to click on, and this is a left click on the first move wire, then I'm holding Control on the keyboard, selecting the remaining move wires, and I'll change this X to 0 and the Y to 53.5. I'll also change the Z values to 50. Then I'm going to select Update and Close. You'll see that changes all of the coordinates there automatically. Now these two I want to be Z5, so it's a little bit closer in the Z axis to make the visual alignment easier. Obviously we don't want it to be 0, because if the part isn't aligned, 0 is going to cause the center of the ball to drive into the face. So the goal is to have it at a value that's high enough for your stylus to clear the face without crashing. So 5 is a good option for this one. It's also worth noting, when we insert move wires, it inserts it with the probe that is currently active. That's really important, because if you've changed probe or changed angle, this will change in here. We want them to be the same as the initial measurement stylus, so that there's no having to go to change racks or change position. If that is the case, in that the active probe isn't the probe you took the initial measurement points with on your first feature, you can easily change it in here to match with the contact points here. So that's also worth noting, just in case you do this later in the program when you've changed probes or probe angles. So now we have that set up, we also want to put a pause message in. So left click on pause, and we'll put a little pause message in. In this case I'll say rotate part to align top slot with stylus. Something like that. Update and close, and then that is now ready to run. So I'll double click this bar again, and I'll go into the feature here, and what I'm going to do is I'll just move this slightly out the way and turn the camera on so you can see what's happening. So if I press play on this feature now, and bear in mind I've deliberately moved this away, like on a slight different rotation. So when we press play, you'll see it drives to 50, it drives down to Z5, and then we get the message on the screen here, rotate part to align top slot with stylus. So in this particular case I'd rotate it until we're visually aligned, like so. I then press OK, and it then goes back up to the 50 and then continues measuring the program. Now every application is different, so those move wire positions will need to be altered. You might even need to add more move wires than the standard 4 that I did. But the idea now is that will run automatically and align every time via that pause message. So the user can rotate it to align it, press play, and it will run automatically. So that is example number 1. This is example number 2. And in this example, we're going to showcase the ability to use a jig or fixture as the reference system. So typically, injection molded parts or casted parts, you might not want to reference off the part itself, you might want to actually reference off the jig or fixture system, or even a mating part. And to do that, obviously we need to access the location points of the jig or fixture and use this as the reference system, then insert a pause somewhere so that we can then locate the part, sit against the mating faces, and apply any clamps, etc. So let's have a look at how we do that. So here is the program that I've created. The key thing is I've utilized the layers function in the software. I'll not go into too much detail on this, but yeah, I've created two layers, one for the jig, one for the measured component, and the idea is I can easily now differentiate between the two on the screen. So I've got the jig measured. I'm referencing off the plane, the intersection of the cone, so that's where it locates, and then a reference line against that side diameter. I've then applied a grid shift on the Z rotation to visually align it how I want. So that's all good, that's all solid. I've then went and sat the part down and measured it and pulled off some related sizes. So that's the seat alignment horizontally and vertically, the seat diameter, and also the seat angle of where it sits against the reference face. The key thing now is if I tried to press play, this would crash. So we need to insert some move wires from the jig measurements before it then starts measuring the component. So the key thing we need to look at is which feature is the last measured feature before we move on to the jig, and that is this circle. So what we're going to do is we're going to right click on this circle and again double click the bar to open it up. And the key thing here is we don't actually need to insert any move wires. You can do them just like the previous exercise. There is applications that will require them, but in this example we're relying on the safety cube or the safety volume of the part being set correctly. So we just want the pause at the end of the rise from the last feature. So if we click on CNC now, you'll see we have the plunge, that's the entrance of the safety cube, all the contact points, so there's all the data of it measuring the part, and then a rise. So if we right click on the rise and say add at end, pause, you'll see there's a pause gets added in at the end of that feature. I'm going to left click on the pause and put a pause message in, so locate component, update and close, and the idea now is it will measure those jig features, which is the reference system. Then when it rises out of the safety cube, it will pause, waiting for this message. We'll then locate the part, press OK, and then it will continue on measuring the remaining features. So let's update and close that. So just click update and close, double click the bar to minimize it again, and then we can watch this run through on the screen. I am going to just make this box a little bit smaller so you can actually see what's going on. We'll put it down here, and then I'll switch the camera on so you can also see what's going on there. So we're going to locate the fixture, remove the part. We're going to press play, so inspection, play, and that's now going to run. So this is it measuring the final feature which we inserted the pause into. So it's taking the contact points now. It's then going to rise to the edge of the safety volume before generating the pause message which you see here. So locate the component. So again, this is where I'm going to locate it on the jig. Fit the clamp, we're good to go, press OK, and then it continues with the program exactly how we programmed it. Just obviously avoiding the collision and giving us enough time to easily locate the part, clamp it down, and then continue with the program. There we go, so we get the summary there, everything's passed, hit the green tick, and again that will repeat every time. This is example number 3. And in this example we have two mating parts, and we want to get the dimension from the bottom seal face to the top seal face as a combined measurement. Now obviously we could try measuring this face and this face in two separate operations, but given the material being slightly softer, it's a plastic rubber style part, I can't take points on every single bit of the surface for both parts. So getting the size where the two parts mate together, i.e. this height from the table to here, as it would operate in the real world, it requires a measurement with both parts together. So you can imagine the initial program is going to be the single bottom mating part. We'll reference off the granite, the center hole and the side face. Then we need to insert a pause so that we can then assemble this ourselves, click it into place as it would in the real world, and measure the top face. This will give us the overall height as a combined measurement rather than guesswork between individual measurements where we can only take a handful of points on both surfaces. So let's have a look at how we would do that. So here is the program I've created. As per the previous exercise, I've used the layers option, the layers feature within View Edit, and separated each part in their own layers. So we have part 1, which is the plane, circle and line on the initial component, and then part 2, which is the plane on the top face of the mating part. That gives us the mating part's thickness, which is the critical dimension for this application. We're looking to insert 2 pauses, one to make sure that the part is clear from the bed before the program runs. That will be inserted into feature number 1, which will be the plane. We then need to add a pause and potentially some move wires into the very last feature before we insert the mating part. So basically we're going to look at feature number 1, which is this plane. So we'll right click on it. Again, we're going to double click this bar at the top to maximize the window and select CNC. So before it even measures anything in the program, because this is the very first feature, we're going to right click on the plunge, insert above, pause. This pause message is a safety feature we're writing in to make sure that the mating part has been removed prior to the program running. This avoids any crashes. So please remove mating part before running. So please remove mating part before running the program, update and close, and that's going to run at the very beginning of the program. So we can now double click the bar again, hit the green tick, and that's written in there. And in this program it goes plane, circle and then line, and then we're going to insert or seat the mating part. So this line is the very last feature that we measure prior to locating the mating part. So we're going to right click on this line to open it up, and just like before, double click the bar along the top to maximize the window, select CNC, and we're going to look to insert some move wires at the before the rise, and then a pause straight after, and that's going to basically let us go very clear of the component, insert the pause message to locate the mating part, and then it will then run on to the next feature. The reason why we want to insert a move wire into this one is to give us enough clearance so that we can actually locate the part without the probe getting in the way. So in this particular case, we'll right click on the rise, insert above move wire, and then right click, insert above pause. Now what we want is we want these values to match the X and Y's of the last approach point, but with a Z value way above the job. So for example, I'll change this to 29.494 minus 9.5, but I'll change the Z value to 150. It's also worth noting, as I've mentioned in previous examples, the probe for the move wire has to match up with the probe used for the feature, or at least the very last contact point. If it doesn't, it's then going to try and do a probe change. So if it's not matching up because you've inserted this later on after a probe change, you can change the probe in this list here. In this example I'm using the same one, so it's not a problem, but it might not be the case for you. So update and close. So it measures the 3 contact points, it then goes to the move wire, which is, again, it's the same position as the approach, only a higher value, so it goes up and clear of the job. It will then read the pause message, so then we can put locate mating part, like so, update and close, and that means it's going to pause for us to locate the mating part. We'll then press OK, and then the program will continue. So we'll click on the form icon now, double click the bar to minimize it, hit the green tick, and what I'll do is I'll switch the camera on so you can see this in action. So camera's on now, there you can go, you can see it. So just to prove out the theory, let's say someone has left the mating part on for the second run. If we press play now, so inspection, play, you'll see there, before it even runs the program, it reads the pause message, so please remove the mating part. So we'll do that now. We then press OK and the program's going to run. Measures the line, and then at the end of this it's going to go to the move wire. So this is the move wire that we put in, so it just goes up to 150, giving us enough room to locate the part and generate the pause message. So locate mating part, which we'll do now. So we sit this in, clip it in place, just make sure that's seated okay, which it is. When we press OK, the program then goes and straight measures the next feature in the list. There we go. Backs off to the safety volume, and that's that complete. So if we look at that now, you'll see we have the dimensions that we require, and that is a successful program where we can insert mating parts in the same routine utilizing a pause. So that wraps up the video.